Welcome to our online course. This is the second lecture about wire cut EDM process. In my previous session, I have covered introduction to wire cut EDM, then process characteristics and working principle of wire cut EDM machine. Today, I am going to cover setup of or system of wire cut EDM, then stratified wire, then process variables and the important applications of this wire cut EDM process. Let us begin with the first point, that is the wire EDM system. Okay, so the working principle of wire cut EDM system already I have taught in the previous lecture. Start with this setup. Okay, so in this wire EDM process there are the 4 units of this wire EDM process. Okay, and this is the setup. So first is your power supply, DC power supply, as I am shown here. The second is the positioning system, that is the second one, and then dielectric system to give the dielectric fluid, and the important, that is wire drive system. These are the 4 important components or the systems of wire EDM machining process. Okay, so one by one we'll go. The first is the power supply system. It is a DC pulse power system. So only difference between this EDM and wire EDM process, because here we are using very small diameter wire as a electrode. Okay, so we cannot expect a very big size craters, so we need a very small craters. For getting this small size crater, we have to use high frequency of the current, high frequency of current having the range 1 megahertz. Okay, and current, okay, that is for small wires which is used for this wire EDM process. Current carrying capacity also less, and it is less than the 20 amperes also. Okay, so you cannot go for beyond the 20 amperes, because whatever the diameter, very less diameter we are using as a wire, so we cannot give more current to the wire. So in that case this wire will break, because due to the high heat generation. Okay, so this is about the DC power supply system. Let us begin for the second part or second component of the wire EDM system, that is the dielectric system. Okay, here I have shown the dielectric fluid flow. Okay, so that system will go. So already I told that deionized water is used as a dielectric fluid in case of the wire EDM system. In wire EDM system, this deionized water is substituted. So kerosene is substituted by deionized water. So because very small gap is maintained in between this wire and the workpiece, so that 25 micron, so this dielectric fluid should have a very high viscosity, low viscosity, and you should have a low viscosity which easily passes through the inter-electrode gap. So efficient flow, to maintain a efficient flow of this dielectric water which has a very low viscosity compared to other dielectric fluid which is used in the wire EDM process, it is easily available and it has a very good desirable thermal properties, because huge amount of heat is generated, and that heat, if it is not removed from the inter-electrode gap immediately, what happen, this wire, it will also become heat up, because it happen both from the wire and also both from the workpiece. So if it is not removed very fast, very quickly, what happen, this wire will break after some time. So that why it should have very good thermal property, so it will cool down very easily. Okay, that is a basic requirement of our deionized water. So it should cool down very easily and should have very availability, easily availability, and also it should have pollution free working. So this dielectric fluid should not pollute the working environment or working area. This dielectric should not pollute, and it should not have any fire hazards. So because total things is not immersed into the dielectric, so there should not be any fire hazard. There should not be any fire hazard in case of wire radiant process. And also high cooling rate is one of the important parameters required for this wire radiant process. Because of this high cooling rate, this whatever the recast layer generated into the workpiece surface, so it's a thickness of this recast layer also reduces if the heat can be released from the workpiece very quickly after melting and vaporization of this crater. So whatever this recast layer generated after each work, it also reduces. Okay, so we get high material removal rate on the workpiece. Okay, and also at the same time tool wear rate also very high, as this wire are not reused. So whatever the tool wear rate is there, so it does not matter because these wire are not reused, because there will be uniform non-uniform cross section of the wire after machining. So it is discarded after using it. So it is discarded after it is used. Okay, it is not reused. Okay, now some additives are mixed, okay, to minimize the rusting also. And if you want to reduce the cost of dielectric fluid, we should provide the way of direct delivery to provide stream of deionized water along the axis of wire. Okay, so cost of dielectric can be lowered down if we can reuse the deionized water after filtration. So it can be reused. This dielectric fluid deionized water can be reused after filtering it. So 5 micron size disposable paper filter is used for the filtering, and the debris particle from the dielectric will be removed. So some additives can be mixed, which I already told, to minimize the corrosion or rusting problem of the workpiece as well as the machine tool by the deionized water. Okay, so this is about the dielectric system. Let us move for the positioning system. Okay, this is the third component of the wire EDM process, that is position system. So these wires has to be positioned very accurately, because we are going to cut a very complicated surface or contour from the workpiece surface. So using CNC control to access control table we can use, and we can use a 2D complicated surface we can use. So this is this one actually this CNC table works in a adaptive control mode. Adaptive control mode is that if there is a, because you are cutting the workpiece in complicated contour, so it sometimes actually wire touches the workpiece surface, and there is a cut off protection circuit is there, and also there is a servo system is there. Servo system, what happen, this servo system actually retract the workpiece away from the wire, and the gap is in between the tool or wire and the workpiece is flushed with the dielectric, so that any debris will be clogged in between this wire and workpiece can be removed. So in case of short circuit, debris bridges the gap or wire workpiece to close, so moves back to re-establish the proper cutting or gap condition. Fourth one is the wire drive system. This is fourth component. So there is a take up grill, and there is a releasing grill is there. Okay, so it delivers the fresh air. A bigger size grill is used, and it delivers the fresh air. Okay, keeps wire always under tension, so there is a wire tension grill is used. Okay, and that is system is used, and it is required so that the wire should be under tension every time. So moves in machining zone as a straight wire, because for better quality of machining surface. And if this wire tension system is not there, what happen, this wire may touch the workpiece surface and it may bend, it may touch to the workpiece surface, so it may generate the taper, streak or vibration marks into the workpiece surface. To avoid such taper, strict and vibration marks for getting high quality machine surface, there is a better wire tension system and also wire guiding system is required. So it minimizes the wire breakage frequently, and wire guides by wire is done by wire guiding system. Okay, so so you can use the wire guide system also. And to minimize the wire breakage frequently and wire guides, okay, we have to use the wire guide system, which is made of the sapphire or the diamond roller, okay, which is made of the diamond and sapphire. Okay, so this wire guiding system, it should pass through the wire guiding system, and it should have the movement towards the take up spool in the series of tensioning roller. Okay, and then nowadays in wire EDM system, I am actually fully automated. Okay, and the wire actually made up of the different metals also. As I have mentioned, the fully automated wire system is there. Okay, for the automatic reloading of the broken wire also. So in during machining, to make the machining process unattended and to make the machining process automatically, nowadays actually automatic reloading of the broken wire is there. Okay, and to enhance the productivity and also to run the machine unattended by the worker, we have to go for the automation. So wire metal may be small diameter wire metal less than 0.15 micron, and it is made up of the molybdenum steel, or if it is larger diameter up to 0.15 to 3 mm. Okay, so in that case copper or brass wire are used, and the wire is discarded after use, after wear at the leading surface due to sparking no longer remain around. Okay, so this is of the wire drive system. There are the many advances in this wire ADM process is there. So today we'll see the one concept about the this wire ADM, that is a stratified wire. Okay, so this is a one concept that is called a stratified wire. In this stratified wire, the core material is made up of the copper and the outer material is made up of the zinc or zinc alloy, as I have shown in the diagram. So this core material is made up of the copper drawn wire, and the drawn thin layer is made up of the zinc and zinc alloy, which has a low melting point than the copper. So if we need higher metal remote, it should carry more current than when using the copper wire only. So wire are not recycled, so not because these are the not expensive, very expensive, and get eroded during the process. Okay, so we are getting the higher MRR, okay, and which carry the more current than using the copper only. Okay, and no need to go for the recycling because it is not very expensive. Let us move for the process variables. Okay, so here I have mentioned the different process variable, that is the linear cutting rate. Okay, it is depend on the thickness of this workpiece metal but not on the complexity of the cut. So it depends this linear feed rate of this wire, it depend on the thickness of this work metal, and higher wire speed is there, that is a 40 mm per second. Okay, let us go for the process characteristics. Because of craters generated, because of this spark craters are generated on the workpiece surface, this matte finish is actually generated, and craters which helps in the retaining the lubricating oil, and which increase the dye life also. And using this process we are getting the surface finish, okay, up to 0.1 micron, okay, in finish pass, and you can keep the tolerance plus minus 7 micron can be achieved. Okay, let us move for the last point, that is the application. So here I have mentioned the different application. This wire EDM process, it can be used for the making dies, fabrication of press tools, again electrode, which is used for the or for other EDM process. So with this we can stop for the wire EDM process. Okay, thank you Ganesh.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.